types. The first type, of course, being you had to determine whether or not it was geometric, and then if it was, you had to tell me the next three terms. So 2, 4, and 6 were that. 2 and 4 were. 6 was not. Is that what y'all got? That whole front side back side thing is not really fair because some people get harder problems, some get the easier ones.
Yeah, but what is it called? When the partner's having struggle, you just help out.
Oh, gotcha. All right. Now the next two, they told you, hey, these are sequences. Write a rule for them. So you had to find your common ratio and then write the rule. So here's number 8 and 10. And there was one more, number 12. And I'll show you it in a second. The only reason people struggle with number 12 is because it had fractions. And everybody hates fractions. So here's the answers, not necessarily the work. Your common ratio was 5 on number 8. So your equation, just as quickly and simply as you can do it, first term, 3, times common ratio, 5, to the n minus 1 power. So if I want to find the 8th term, I plug in 8. Number 10, the common ratio was negative 3. So again, as easy as you can imagine, a sub 1, negative 1.5, times r, negative 3, raised to n minus 1 power. So if I want to find the 8th term, plug in 8. And then here's number 12. Again, the only reason that was harder is because of fractions. But your common ratio in there, if I did 8 over 27 divided by 16 over 18, your common ratio was 3 halves. So there's your equation. And your a sub 8 was 27 over 8. Questions on that one? In my opinion, the hardest section was the next section. This is where you had to use the equation to kind of work backwards. So here's number 14 and 16, where you had to kind of work backwards with a sub n.
Interruption at this time. We need all show choir members to report to the choir room at this time. All show choir members report to the choir room.
Does anybody know what that's about?
Yeah, they go to the middle school.
All right, so on number 14, you needed to find a sub 1, so you could then go find a sub 4. So a sub 1 was negative 8, and then the equation, of course, that let me find a sub 4, we could write it. And then number 16, you need to find your common ratio, which is 0.25, and then your second term of 600. Questions with 14 or 16? Most of y'all finished this in class yesterday, or at least a good portion of it. I think we answered most of the questions yesterday. All right, so last two were pretty simple. Again, they told you they were geometric sequences. So you found the R. The difference was to find the series. S sub 8 and S sub 10, we used what on these problems? We used that big E, right? So for example, we did from the first to the 8th term, and once I found that common ratio, I simply plugged in the first term, 18, times that common ratio, negative 0.5, raised to the x minus 1 power. It's very simple. That's all you had to do on those problems. So if you remember that, that'll be an easy problem moving forward as well. Questions? Anybody? Okay. So a lot to do today. We are going to move into a section where the challenge becomes this homework assignment is not arithmetic. Guys, I hate having to compete. You know, once we get started, I need y'all to stop doing that. It's happening back there. It's happening right here. If it happens over there, it's just everywhere. Anyways, today, the challenge is we're not in the section that says arithmetic sequences. We're not in the section anymore that says geometric sequences. We're now kind of putting it all together, and you have to look at problems and determine whether they're arithmetic, geometric, or even neither. So it's kind of a review, what we're doing today. There is one new thing. So once I go over that one new thing, you are more than welcome to go ahead and start your homework assignment. It's posted up on the top right corner of the board, numbers 1 through 6, 10 through 13, 18 through 21. Nope, I did a new one. For you guys who got this from me before you left, I decided to do a different one. It's got a little bit more on it. Yeah, you won't need that. So I'm giving you the note sheet and the homework sheet right now. Well, you already done that. You've already been a little sensitive today. Not a little, I mean a lot of.
I don't like the way these numbers No.
My mom used to say, Nina, she used to say, save the pieces. And I would break something. Are you okay? The one that says no, you don't have to apologize. I'm not messing with You are so welcome. I know Abby was fun tonight. Now you can be ahead of the game, Abby. You know? Maybe it'll make you swim faster. To know that you already have that piece of paper. That's what we're hoping. Okay, so we are going to do two things real quick. One, remind me, if it's arithmetic, what is the equation that you will need to write? Come on, help me out. If it's arithmetic, what is the equation that you'll need to write? A sub 1. Nuh-uh, that's geometric. Arithmetic. A sub 1 plus n minus 1 times that common difference. That's what you'll do if it's arithmetic. Let's go ahead and get this on this paper. That way you know. We're using that if it's arithmetic. What do you use if it's geometric? A sub n equals A sub 1 times r raised to the n minus 1. There it is. Arithmetic, geometric, or of course if it's neither, you're not going to write an equation. You're going to say neither. Now, we're going to come back to this in just a minute. We're going to skip all the way to the end, to the applications. So go to the back of your page. We're going to skip to the applications. On your homework tonight, your applications are 18 through 21, as you can see. That's part of your homework assignment. All right? So, here's what we're going to do. We're going to determine whether these are arithmetic, geometric, and then based on that, we're going to solve the problem that it's asking. So I'm going to read this. Ian is playing a video game. The number of points he has earned after every hour is shown below. Determine whether this represents an arithmetic or geometric sequence. Then, find the approximate number of points he earned after 9 hours. Round your answer to the nearest hundredth. Okay, so what am I looking for first? What am I deciding first? All right, so I look at my values, right? And I'm trying to determine, are these values representative of arithmetic or a geometric sequence? So, what do y'all think? Does it look like I'm adding the same thing every time or multiplying?
Adding.
All right, so I check that. and I don't know why I marked them all out. I tried to highlight it. If I try adding, I would go and check to see if it had a common difference, right? How do we check to see if it has a common difference? Second term minus first term. What is 480 minus 384? It's 96. Guys, does 480 plus 96 equal 600? Then it's not arithmetic. So my assumption, it has to be what? Let's check it. 480 divided by 384. Go type that in your calculator. Tell me what you get. So let's check to see if it's multiplying by 1.25 every time. Go 480 times 1.25. What do you get? There it is. So I know for sure it has to be geometric. Right, Caden?
Yes, sir.
So what would my equation be for this geometric sequence? 384 times 1.25 raised to the n minus 1 power. Correct? That's it. Now, we got to answer the question. So here's the tough part. I've got to decipher whether I'm finding a sub 9, where I'm just finding after the 9th term, or am I finding s sub 9? Am I taking the points earned after every hour and giving a total accumulation of points? Are y'all with me? So what does the question ask? Find the approximate number of points earned after 9 hours. Guys, is that all of them or just 9? It's just 9. So we're finding a sub 9. A sub 9. So I go to my calculator and I type in 384, open parenthesis, 1.25 raised to the 9 minus 1 power, and how much was earned after the 9th hour. All right. So it's set around to the nearest 100. So 2,288 point, what'd you say? 82. Was that what you got? 82. And there it is. That's how you do it.
Why is it not all of them?
Because it just says after 9 hours.
So if it were all of them, it would be like all the points.
Yes, it would say something about a total.
Like on the next one.
Like on the next one. And actually the last one too. All right, look at this, number 19. This one doesn't give me a chart. All right, so I have to pay attention to what this problem is telling me. Michaela is building a pyramid of paper cups. Y'all know what a pyramid looks like, right? That's a pyramid. The bottom row has 61 cups in it. So this bottom row right here has 61 cups. And the top row has only 1 cup up there. If there are 16 total rows, and the number of cups on each row represents an arithmetic sequence. So they actually tell me. I don't even have to think. So we know we need a what? We need a common difference. We need a common difference. All right, so in the past, we found common differences by taking the second term and minusing it from it the first term. But what do I not have? I don't know the second term and the first term. I only know one of those two. But what else do I know? I know the last one. And how many are there? So I know how much the first has and the last. How many did the first term have? You could go either direction.
61.
Either direction. If you want to say that a sub 1 is 1, you could. If you want to say that a sub 1 is 61, you could. It really doesn't matter as long as you have one in one spot and one with the other. When I did it, I did a sub 1 equals 61. It wouldn't matter. If I did a sub 1 is 61, I have to do a sub 16 is 1. If I did it the other way, reverse that. Now remind me, How else do we teach that you could find the common difference?
61 minus 1 over 1 minus 16.
That's right. We can do the difference of your values over the difference of your numbers, right? Difference of term values over difference of term numbers. Remember that's the time I said that the order doesn't matter, but then it does matter? So if you do, like Braden did, 61 minus 1, since I went in that order, I have to do what? 1 minus 16. If I had done 1 minus 61, that's fine, but you would have had to done 16 minus 1. Your orders have to match. You can't compare apples to oranges on top and oranges to apples on the bottom. It's got to be compared correctly. Now, if you do this, you're going to get 61 minus 160 over negative 15. So your common difference is going to be negative 4. If you went the opposite direction, your common difference would have been positive 4. It would work out the same way. I promise. So, we're almost done. Our equation, because this is arithmetic, is a sub 1, what's that? Plus n minus 1 times negative 4. So my equation, 61, what is negative 4 times n? Negative 4n. And what's negative 4 times negative 1? Positive 4. So my equation is negative 4n plus 65. Okay? Now, let's answer the question that they asked. At the very end of all this, it says, find the total number of cups. So that's talking about taking every row and doing what? Adding them up. Guys, how do we do that? We use the big E. So go to your calculator, go alpha window number 2, and we're going to go from the first to the 16th row for the equation negative 4x plus 65. See? That's where we know we have to do S sub 16. We're adding up all of the terms, all of the rows through the 16th term. And how many cups are there total? 496 cups. Okay? So you're applying an arithmetic sequence here. You applied a geometric sequence before. Number 20. The amount of interest that Ben earned on his savings account for the past 3 years since opening the account shown in the table below. Determine whether this pattern represents an arithmetic or geometric sequence. Then, find the total amount of interest that Ben will earn after 20 years. Okay, so first I need to determine what? Is it geometric or is it arithmetic? What does it look like to y'all? What's your instinct tell you? Okay, so I'm going to try common difference. So that's 79.20 minus 72, which is $7.20. I'm going to add 7.20 to 79.20. Does it equal 87.12? No. So it's not what? It's not arithmetic. So it's got to be geometric. So let's figure it out. 79.20 divided by 72. What do you get? Let's check that. What's 79.20 times 1.1? There it is. It's geometric. So, really easily, my equation is a sub 1, 72, times my common ratio, 1.1, raised to the n minus 1 power. So all we got to determine is what?
The total amount after 20 years.
So do we want to do a sub 20 or do we need to do s sub 20?
That's a 20.
It's s sub 20, right? We're taking all the interest that you got every year. 1 year, 2 years, 3, all the way through 20 years, and it's accumulating the total amount of interest. So we're using big Big E. From the 1st through the 20th year, for the equation 72 times 1.1 to the x minus 1 power. You type that in, it will spit out the answer, $4,123.80. Questions about those application problems? So not too bad, right? You're applying the idea of geometric and arithmetic sequences. Now let's go back to the front side, and this really is just kind of a review, okay? The reason that we're doing it now is because instead of it being, hey, this is an arithmetic sequence homework assignment, or hey, this is a geometric homework assignment, it could be either one. So you kind of have to look at it, kind of go with your gut, check it, and if that worked out, great. If not, then maybe it's the other one. So for example, number 1. For 1 through 9, they want us to determine whether it's arithmetic, geometric, or none, and then based on what it is, write the formula. So if I look at number 1, what do you notice about our pattern here? Isn't it going back and forth from positive to negative, positive to negative? Can arithmetics do that? Can arithmetic sequences go back and forth? No, because think about it. You're either adding the same number every time, or you're subtracting the same number every time. If you're adding or subtracting the same number, can it go positive, negative, positive, negative, positive, negative? No chance. What could do that, though? Geometric sequences, right? What allows it to go back and forth from positive to negative to positive to negative? Multiplying by a. So I'm going to check to see if this has a common ratio. That's the only thing it could be, doing that. So I take the second term, which is, and I divide it by the first term, which is
4.
What's negative 20 divided by 4?
Negative 5.
Negative 5. So let's see if that's what it's doing. What's negative 20 times negative 5?
100.
100. What's 100 times negative 5?
Negative 500.
Then this is definitely geometric. Definitely. So let's write our rule. And this is real easy because you got the formulas right above you, don't you? A sub n equals, what's the rule? A sub 1, which is 4, times r raised to the n minus 1 power. Done. You can't simplify it. It's done. Question. I'm going to skip number 2. It's another geometric one. Again, this is just review. Look at number 3. Isn't it also going back and forth from positive to negative, positive to negative? So the only thing it could be is geometric. So I'm going to check it. I'm going to check to see if it has a common ratio. So that second term, negative 2, divided by first term, 1. What's negative 2 divided by 1? So let's keep multiplying by negative 2. What's negative 2 times negative 2?
4.
4, not 3. So what's that mean?
It's not geometric.
It's not geometric. It can't be arithmetic because arithmetic can't go back and forth, back and forth. So this one is simply neither. With me? No? Okay. Number 4. Look at it. Just on your instincts, what's it look like it's doing? It looks like it's adding the same number. So I check to make sure it has a common difference. Adding, right? Arithmetic, common difference. So I take negative 11, second term, and I subtract the first term, negative 18. Well, minus the negatives plus. Negative 11 plus 18, sure enough, 7. So let's see if Caden's right. What's negative 11 plus 7?
Negative 4.
What's negative 4 plus 7?
3.
He was right. Every time it's adding 7. This is arithmetic. So what equation do I use? A sub n equals A sub 1, negative 18, plus n minus 1 times 7. What do we do to solve this problem? Yep, you're right. You distribute 7. 7 times n is 7n. 7 times negative 1 is minus 7. Remember I told you I always want you to bring down your variable part first, 7n?
We have to solve it.
Well, I mean, you got to write the rule.
I know. I thought you just wrote the formula.
Well, this is the formula. But for arithmetic sequences, remember when you initially type in your common difference, you still need to simplify the equation. With geometric, we don't have to, but this one we do. So negative 18 minus 7, negative 25. So this equation would simplify down to 7n minus 25. So I would like you to do that, yeah. Now look at number 5. And this is the last one I'm going to do before we skip on. Number 5, what does it look like? Like your first impression of it? Does it look arithmetic?
No.
No. Does it look geometric? You might even think, well, maybe.
Well.
Right? So you might check to see if it has a common ratio. So you take 8 divided by 1, that's 8. Does this thing keep multiplying by 8?
No.
So, neither. So tonight, on your homework, you're going to have 1 through 6 that do the same thing. And out of 1 through 6, guys, 2 of them are neither, 2 of them are geometric, and 2 of them are arithmetic. I'm going to go ahead and tell you that. Okay? So you have one section over applications. You have one section over what we just did, neither, arithmetic, and geometric. There's 2 of each. And then you got one more section that comes from right here. What's the difference in this section and the last? Are y'all with me still?
Find the sum.
Find the sum. So won't we need to do big E? If I do big E, though, don't I still need an equation? See, I'm going to do big E from the 1st to the 26th term. But don't I need the equation? And on number 11, I'm still going to do big E from the 1st to the 14th term. But don't I need the equation? So what's still a requirement here? I've got to figure out, 1, is it,
Arithmetic or geometric?
and then what is my
Sum.
what's my rule?
Oh.
What's my equation, right? So look at 10.
Mr. Costello,
Yes.
is Eduardo in class right now?
Who was it?
Eduardo?
Yes.
He is. Okay, he was marked absent first period, so I'll fix it.
Gotcha. Okay, thanks.
Thank you.
Were you here first period? Okay. So what does this look like initially to you guys? Does it look arithmetic or does it look geometric? Go with your instinct.
Arithmetic.
Looks arithmetic. So let's see if it has a common difference. That second term, negative 1, minus first term, 3. What's negative 1 minus 3? Is that what's happening? Is it subtracting 4 every time? Then you picked right the first try. So my equation is a sub 1, 3, plus n minus 1 times that common difference we just found, negative 4. I'm going to distribute that. What is negative 4 times n? Negative 4n. What's negative 4 times negative 1? Positive 4. So here's my equation that I'm going to just throw directly into my summation. Negative 4n, and then 3 plus 4, 7. So alpha, window number 2, define your variable from the 1st through the 26th term for the equation negative 4x plus 7. And that will find S26. Has anybody done that for me yet? Negative 1,222. I know a lot of y'all are working on your homework, so I'm just going to kind of go through this, which is fine. I gave it to you so you could go ahead. Number 11. I look at this problem and I think, well, it's getting half the size, right? That's not arithmetic, that's geometric, so I check it. I check to see if it has a common ratio. That's what I think it is, that's what I'm going to go with. So negative 30 divided by negative 60, right? Second term divided by first term is 1/2. Sure enough, that's what's happening. Every time it's getting half the size. It's multiplying by 1/2. So my equation for this geometric sequence is negative 60 times 1/2 to the n minus 1 power. So if I'm trying to find the sum through the 14th term, I'm going to do big E, right, alpha window number 2, from the first through the 14th term for the equation negative 60. Remember, open up a new parenthesis, 1/2, close that parenthesis to the x minus 1 power. Somebody asked me in the last class, could I have used 0.5? Of course you could. That will still find the sum through the 14th term. So here are your two options for this answer, and then I'm done. If you left it a fraction, it's negative 245,745 over 2048, which makes no sense to people. Or you could have changed this to a decimal, which I probably would have recommended here, and it's negative 119.99. So if you put negative 120, that too would have been fine. You've got two problems there below that where all you have to do is type it in your calculator. Very simple. So your homework, 1 through 6, where you have 2 neithers, 2 arithmetic, and 2 geometric. Trust me. If you get something different, you made a mistake. You got 10 through 13 where you have to use summation, big E. And then you got 18 through 21 where you have to apply. So that's your assignment. Tomorrow we'll come in, we'll go over that real quick, and then we will review for a test. Questions?